Welcome to the deep dive. If you've ever tried to start a new project in the functional programming world, specifically with Haskell, you probably know the feeling.
Oh, yes. That mix of excitement and then suddenly a wall of confusion.
Exactly. You run a simple command, maybe cabal init, and you get hit with a setup prompt that makes you question if you even know what language you're using.
That's a classic hurdle. The prompt asks you to choose a language for your library.
And the options are Haskell 2010, Haskell98, GHC 2021, and GHC 2024. I mean, to a newcomer, that looks like four totally different, maybe incompatible programming languages.
And that's the core of the problem. Yes, genuinely a confusing prompt because it's lumping two very different concepts together under that one word, language.
So that's the confusion we're going to clear up for you today. Our mission for this deep dive is to really pull that menu apart.
We need to draw a very clear line between what are formal, official language standards.
And what are these more practical, compiler-specific things, these extension bundles, or as people call them, dialects?
Understanding that distinction is, well, it's fundamental. It affects everything from your project's portability to your ability to use the latest, most productive features.
We'll go through each of those four options, explain what they really are, and then give you a clear recommendation for what you should probably be choosing for a new project right now.
To get started, let's just state the basic fact. Haskell is one language. How it evolves is just managed by these two different forces.
Okay, so let's unpack that. If they're not different languages, what are they? What am I actually choosing?
You're choosing a snapshot of features, really, a default set of capabilities that are turned on from the start.
And to talk about new capabilities, we have to talk about the main engine behind all this innovation.
The giant in the room.
Right.
Which is the Glasgow Haskell Compiler, or GHC. There are other compilers, sure. Some are historical, some experimental, but for all practical purposes.
If you're doing serious Haskell development today, you're using GHC.
You are. And that's the key to this whole deep dive. Two of those options on the menu are about formal standards that work on any compiler.
And the other two?
The other two are GHC-specific feature packs, the dialects. They're built for GHC's cutting-edge power.
Okay, let's put GHC on the shelf for just a minute and talk about the foundation. The official standards. Haskell98 and Haskell2010. What are these?
These are the formal, community-driven specs. Think of them as the agreed-upon definition of the language at a certain point in time.
So they're all about guaranteeing maximum portability.
Exactly. Any compiler that says it's a Haskell compiler has to support these. They're the universal rules.
So let's look at the first one, Haskell98. The name alone makes it sound a bit dated.
It is. You should pretty much just skip it. It's really only there for maintaining very old legacy code.
So for anyone starting a new project today, it's not a real choice.
Not at all. Haskell 2010 is the most recent official standard. It's the absolute foundation for any modern Haskell.
And here's where it gets really interesting, because Haskell 2010 wasn't just a minor update. Our sources make it clear that it introduced features that completely changed the game.
It was a huge leap forward. It took Haskell from being, a fantastic research language to being a practical industrial strength tool.
So what were those killer features? Let's get specific.
First and foremost, the foreign function interface. The FFI. Before this, talking to code written in other languages, like C, was a nightmare.
It was all compiler-specific hacks.
Right. The FFI standardized it. It let Haskell talk to the huge world of C libraries, which means talking to operating systems, graphics libraries, everything.
So modern Haskell development as we know it, building real applications.
It wouldn't exist without the FFI. Simple as that.
Okay, so that's external communication. What about internal structure?
The 2010 standard also formalize hierarchical module names, things like data.list or graphics.stl.
It lets you organize your code, essential for any big project.
It is. But maybe the most important feature for our discussion today was the introduction of compiler pragmas.
Ah, yes. Those little hashtag language comments you see at the top of Haskell files.
Exactly. That's the mechanism that allows a developer to turn on extra features that go beyond the base standard.
So the community created a stable baseline with Haskell 2010, but they also gave everyone an official way to opt in to new experimental stuff.
That's a perfect summary. The pragma system is the key that unlocked the modern GHC ecosystem. It let GHC innovate rapidly without waiting 10 years for a new official standard.
That's a huge piece of the puzzle. We've got the standards, Haskell98 and Haskell2010, which are about stability. Now let's pivot to the GHC dialects. GHC 2021 and GHC 2024.
Right. This is where we move from the formal rules to the practical day-to-day experience of writing Haskell.
So what are they exactly?
They're not new language standards.
Yeah.
They are extension bundles or dialects. They're just convenient, curated collections of GHC's most popular and stable extensions.
So wait, if I chose Haskell 2010 and I wanted all the modern goodies, I'd have to write out, what, 20 or 30 of those language pragmas at the top of every single file?
You absolutely would. And that's why these bundles are so great. They save you from that massive headache. They just turn on a whole pre-approved set of features for you.
It's a huge quality of life improvement then.
It is. Think of it like buying a car. Haskell 2010 is the base model. GHC 2021 is the premium trim package.
It's the same car, but all the best optional extras are already turned on.
Precisely. You're not changing the language. You're just enabling a whole set of sophisticated plugins on top of that 2010 baseline.
Okay, so let's compare the two bundles on the menu. GHC 2021 versus the new GHC 2024.
GHC 2021 is what I'd call the current sweet spot. It's a very stable, widely supported set of extensions that are mature and well understood.
It makes the language more powerful, more ergonomic than just plain Haskell 2010.
Much more. Most production environments are pretty much standardized on GHC 2021. It's the safe harbor.
And GHC 2024, the new kid on the block.
Right. It's the newer bundle. It takes everything from GHC 2021 and adds a few more recent, cutting-edge extensions that the GHC team thinks are ready for prime time.
So it's the latest and greatest. Why wouldn't everyone just jump straight to that?
Because that bleeding edge comes with a very important string attached, a strict requirement.
Okay.
To use GHC 2024, you need a very recent version of the compiler, specifically GHC 9.1 or newer.
And that's a high bar, isn't it? Especially if you rely on, say, the version of GHC that comes with our operating system.
It's a very high bar. If you're using a stable Linux distribution or even the recommended stable version from a tool like GHCUP, you probably don't have GHC 9.0 yet.
So if I pick GHC 2024, my project might just not build. For me or for my colleagues?
It very well might not. The risk of your build environment breaking because the compiler is too old often outweighs the benefit of a couple of new language features.
You're essentially committing yourself to living on the bleeding edge of the tool chain.
You are. And unless your project has a very specific need for a feature that's only in that 2024 bundle, the risk of instability and dependency hell just isn't worth it for most people right now.
Okay, that clarifies the whole landscape beautifully. We've got portability on one end, bleeding edge features on the other. Let's synthesize this into a clear recommendation list for someone starting a new project today.
Let's do it. 4 simple rules based on your goals.
First, the no-brainer.
Skip Haskell98. It's for legacy code only, not for new projects, period.
Number 2, your goal is maximum compatibility above all else.
Then you choose Haskell 2010. It's the universal baseline. Your code will compile everywhere. But, and it's a big but, you'll be manually adding pragmas for every modern feature you want to use.
Which brings us to number 3, the professional default.
Choose GHC 2021. This is the recommended choice for most modern libraries and applications. It gives you a massive productivity boost with stable, mature features, and it's compatible with the GHC versions people are actually using.
It's the path of least resistance.
It absolutely is.
And finally, the specialized bleeding edge choice.
You choose GHC 2024. Only if you need a specific cutting-edge feature from that bundle, and you are prepared to manage a very recent GHC toolchain for yourself and your entire team.
So the takeaway for you, the listener, is that the choice you're making is really about what environment you're targeting.
That's it. You're not choosing an incompatible language. You're just choosing how many stable plugins you want GHC to turn on for you right from the start.
So we've moved from that confusing startup menu to, I think, a really clear picture of the Haskell ecosystem. We've distinguished the official rules from the practical GHC dialects.
And you now have the tools to look at that menu and make a smart, informed decision based on your project's actual needs.
What's really fascinating here is this natural tension you see in any mature language. You have the community, which creates a stable standard like Haskell 2010 to ensure things don't break.
But then you have the dominant tool, GHC, which has to keep innovating to meet the demand for more powerful features.
And these GHC dialects, they're the solution to that tension. It raises a really interesting question for you to think about as a developer. In a field that moves this fast, how much stability are you willing to sacrifice for immediate access to the bleeding edge of functionality?
Something to mull over as you spin up your next Haskell project.
Thanks for joining us for this deep dive.